Hello everyone, I'm Mustafa Emir Çağlayan, second year MBG student at Bilkent. Today I'm excited to share my Physics 101 lab project. I explored the experiment of investigating collisions with balls. The experiment delves into the energy conservation and the dynamics of collisions using simple tools, balls, a ram, and some basic physics principles. Let's break down the procedure for each part. Part A, titled Conversion of Potential Energy to Kinetic Energy. I started by calculating the mass of the ball and then measured the height of the ramp. After releasing the ball, I recorded that time it took to reach the bottom. Using this data, I calculated the practical velocity and acceleration of the ball. Next, I compared these results with the theoretical acceleration obtained from the ramp's angle and the gravitational acceleration. Now let's look at the experiment. Part B, elastic collision of balls. This part involved dropping one ball and releasing another from a compression spring to collide mid in the ramp. With the help of recorded video, I determined the time delay between the releases. After collision, I measured the practical velocity and acceleration of the first ball and compared these results with those from part A. Now let's look at the part B. Part C, opposite direction collision. In this final part, I dropped one ball from a height and collided it with another coming from the opposite direction, held by a compression spring. The goal was to explore the relationship between compressive distance and the first ball's energy. Now let's look at this part C. When we look at the calculations for part A of the calculation, I found my velocity practical by distance divided by time. Then I found the acceleration practical by dividing my velocity with time. After that, I compared them with theoretical results. Velocity theoretical is obtained by potential energy to kinetical energy conservation, and then I found the acceleration theoretical by taking sinus of the ramp angle. Then looking at the comparison, it came pretty accurate with little loss of energy. Now let's look at part B. I used to looked at the kinetic energy conservation by taking the results from part A, then compared it with the collision results. Here is my the data, and I found the K constant of the compressive spring by using Hooke's law, and I used a Newton meter for that. In the part C, I looked at the total kinetic energy before and after with the formulas here. These are formulas for this initial and last speed for the balls. Looking at the tables, the results were pretty accurate. The part C has highest error among them, which could be because of the collision of opposite directions, since it may generate heat and some energy may be lost there. Other than that, the error was little less. That's all. Thank you for listening my experiment.